Good morning to all. Today we are going to understand about the glass. In this lecture we will understand what is glass, how it is prepared and what are the types of the glasses. Glass is a solid material that lacks a specific melting temperature and it has a high viscosity which inhibits crystallization. Upon the application of heat, glass undergoes a gradual softening process and eventually transforms into a liquid state. Glass is any substance that has solidified from a liquid condition without undergoing crystallization. ग्लास एक amorphous substance है with a high level of hardness, its brittleness and transparency or translucency. It is formed by the supercooling liquid, supercooling a liquid to a state of infinite viscosity. And the substance is required from a fusion of a blend of various metallic silicates, often composed of sodium, potassium, calcium, and lead. It lacks a distinct melting temperature. It has a precise formula or crystalline structure which can be expressed by this way: XR2O YMO 6SiO2, which represents a compound where R represents an atom of a monovalent alkali such as sodium potassium. M represents an atom of bivalent metals such as calcium, lead, zinc, and X and Y are the whole numbers which can be uh, treated as a number. In particular case, if we put the values of x and y, then we will get an ordinary glass which is known as soda lime glass, means Na2O CaO 6 SiO2. In some glasses, SiO2 may be replaced by aluminum oxide or barium oxide or that phosphorus oxide, phosphate. Al2O3, B2O3 and P2O5. We must know about who is behind the glass preparation, and we know Edouard Benedictus, which is a polymath from France. He was credited with the discovery of safety glass in 1903. He assembled triplex by sandwiching a layer of collodion between two pans of glass. What are the general properties? Glass is a substance without a crystalline structure and lacks a specific temperature at which a transition from a solid to liquid state takes place. It has the ability to absorb, reflect, or transmit light, which and can achieve a high level of polish. It possesses excellent electrical insulation properties and is susceptible to the effects of alkalis. It remains unaffected by air, water, acid, and most chemical reagents, with the exception of hydrochloric acid, which transform its silica into silicon tetrafluoride. What are the composition and ingredients of the glasses? Glass, we must know there are different ingredients. First of all, soda lime glass, which is a type of silica based glass. It is commonly used for glazing and container. It is made up of 75% of silicon dioxide, sodium oxides derived from sodium carbonate, calcium oxide, which is also known as a lime from CaCO3, and a few other small additives. The second one is silicon dioxide, which is a prevalent elemental composition of glass. Sodium oxide, that is the third one, is often derived from Na2CO3, which is commonly known as soda, which reduces the glass transition temperature. The soda renders the glass water soluble. Characteristics that is typically undesired transparent glass and with the low melting point and a smooth texture. We have the another types ingredient, that is lime, which is also known as calcium oxide, is a typically derived from limestone, which is composed of CaCO3. Magnesium, the another ingredients is magnesium oxide and aluminum oxide that are included to enhance the chemical durability. The soda lime glass, which is the end product, consists of approximately 70 to 74% silica by weight. Approximately 90% of the all glass produced is composed of soda lime glasses. Potassium is commonly referred as potash, which is its chemical formula is K2CO3, that is used in durable glasses. Potassium, that is potash, it is also used in hard glass. Calcium, in a way, limestone, chalk and lime. Lead and litharge and red lead, that is flint glass, used in flint glass. These are the some uh, ingredients like silica, quartz, white sand, ignited flints, zinc, zinc oxide, heat and shock proof glass for the preparation of heat and shock proof glasses. Borax and or borax, borate or borax, the boric acid, chelates or pieces of broken glass to increase the fusibility, and ultimately the last ingredient, but not the least, that is the colors. Yellow ferric salt, green ferrous chromium salt, blue means if you want to change the color of glass yellow, we need to add ferric salt. If we need to convert into green, we need to add ferrous and chromium salt. If we want blue color, that is cobalt salt. Purple, magnesium dioxide. If you want red glass, we need to add nickel salts or Cu2O. If you want neon yellow, we need to add cadmium sulfide. If our requirement of the glass is fluorescent greenish yellow, we need to add uranium oxide. If you want opaque milky white cryolite is required to add on it, or calcium phosphate. These are some ingredients which are used to prepare the glass. Now, how to manufacture glass? This is the furnace we have displayed here. The manufacturing process that can be categorized into four stages. Number one is melting, the second one is shaping or forming, the third one is annealing, and the fourth one is finishing. We can see here the type of the way how the manufacturing of glass is taken place. The hot flame at the temperature of 1800 degrees centigrade is supplied to the mixture of soda ash, limestone, sand, chelates for the preparation of glass. Why it is? Because number of other ingredients we have, what we have just learned earlier slide. So these are mixed and they are taken into the tank furnaces, and this tank furnace will mixed all the ingredients together with the help of the gas air, which is slightly higher in temperature. Even 1800 degree centigrade is sufficient, and sometimes more temperature is required to uh, combine all the ingredients together. And finally this huge furnace is manufacturing process is required to prepare to manufacture glass. And first of all, what a kind of melting is there, we need to understand. The raw materials, sand, soda ash, limestone are combined with a chloride in the correct proportion. This mixture is known as a batch, and this batch is finally powdered and then fused together. The fusion process takes place either in fire clay pots of high grade glass or tanks that are part of the open hearth furnace. And the heated material is been uh, given the temperature is given it to the through the mixture produces gas, and under the high prevailing temperature condition, that is about 800 degrees centigrade, the charge and it goes melting and fusion. This furnace is 38 centimeter in length and 9 meter in width and 1.5 meter in height. It has capacity of 1350 metric ton. The glass is created by liquefying in the center of the furnace, with the flames move back and forth from one side to another side. The melting process, commonly soda glass, consists of the following sequences. We have some chemical reactions here, and we are just watching that in this particular reaction the carbon dioxide is liberating. So the number of all the carbon dioxide released from the molten mass, it declares it like MnO2 or niter are introduced to eliminate any ferrous compound in carbon if they are present. At this point, if a tinted glass is desired, the coloring salts are introduced. The heating process is continued until the molten mass is completely devoid of bubbles. Especially the bubbles are not should not present in this furnace. And the glass balls, then it is cooled at around 800 degrees centigrade, because most important thing is all the carbon dioxide gas need to required eliminate from to release from this molten mass. The second is the forming and shaping. The glass is currently formed by either mechanized or manual molding technique. In machine molding, the glass mission design should prioritize and completion of the object within a short time frame. Within this very brief duration, the glass undergoes transition from viscous liquid state to a transparent liquid. Therefore, the design of machine that satisfies the requirement of heat, flow, metal stability, and bearing clearance is highly intricate. Now, we have a number of advancement in the technologies. The glass engineering is capable of successfully completing the given responsibilities. Now the third one is annealing. It is a process that involves heating a material, then slowly cooling it down to reduce its hardness and increase its ductility. It is a method by which it is achieved. Annealing comprises two steps. The one is maintaining the glass at a certain temperature above a specific critical point for a sufficient duration to decrease internal tension to the process of plastic deformation until it reaches a predetermined maximum level. The second was gradually cooling the bulk to a room temperature at a rate that ensures the strain remains below the maximum limit. Subsequently, glass products are permitted to undergo a gradual cooling process to reach the ambient temperature by traversing various chambers with progressive decreasing temperatures. Now, these are some third process in a manufacturing process. So we have this annealing. Now the final stage of the manufacturing is the finishing. Finishing means how the annealing process processed the things, how the glass is cooled, and finally all the glass articles which undergo several physical operations, that is finishing processes including cleaning, grinding, polishing, cutting, and sandblasting, enabling grinding and glazing. All these are processes that has been conducted to shape a certain glass in a certain manner. So there are four types of four steps we can say for the manufacturing of the glasses. Now we understand how the number of types of and the glasses are present in there. Soda lime or soft glass is there. Soda lime or soft glass, it refers to a type of glass that has a soda and lime and as its main components. The primary constituents include silica, calcium carbonate, and soda ash. Their composition can be approximately Na2O, CaO, 6SiO2. They have a low cost resistance to vitrification, exhibit a moderate level of water resistance. इसके जो that their high melting point, they possess a low resistivity to heat that can be easily manipulated through the heat working process. The application, they are extremely utilized in various industries like window manufacturing, electric lighting, glass production, construction material, and affordable tablewares. These materials are preferred when there is a little need for a great resistivity to the high temperature of chemical stability. The second type of the glass we have, that is potash, lime, or hard glass. This glass variant is derived from silica, that is sand, calcium carbonate, and potassium carbonate. The composition is like K2O, CaO, 6SiO2. These types of substances has my high melting point, are they are resistivity to fusion, resistance to fusion, and are less reactive to the acids, alkalis, and the solvents compared to the regular glasses. The third one, we have the lead glass or flint glass. This glass variant is produced by employing lead oxide rather than calcium oxide to fuse with silica. Up to 80% of lead oxide is included to dense optical glasses. K2O is employed, so the composition substance is there, K2O, PbO, 6SiO2. Lead glass is significantly costlier to produce than regular lime soda glass. However, that is considerably more malleable and manageable. Lead glass exhibits a lower softening temperature compared to the solid soda glass. It possesses some exceptional electrical characteristics, and they have high level of brightness, shiny appearance, specific gravity ranging from 3 to 3.3. And the fourth one is borosilicate glass, that is also known as Pyrex glass or Jena glass. This variety of glass is a prevailing type among the durable glasses found in the business sector. These glass mostly consist of silica and boron with a little presence of aluminum and acrylic oxide. The percentage given in the standard formula on the of the glass, that is 80.5% silicon oxide, 13% B2O3, 3% Al2O3, 3% K2O, and we have only 0.5%, that is Na2O. Replacing the alkali Na2O and basic alkaline earth oxides CaO in soda lime glasses with boron and aluminum oxide, it produces glass with a low thermal coefficient of expansion and strong chemical resistivity. And this borosilicate glass has a exceptionally elevating softening temperature and have outstanding resistivity, and there are more comfortably known as a good glass, that is pyroglass. There are other types of the glasses: aluminum silicate, vitrosil or silica glass, safety glass, optical or Crookes glass, polycrystalline glass or pyroceram glass, toughened glass, insulating glass, wire glass, laminating glass, glass wool. These are some glasses, other glasses, and some characteristics of the glasses are there. It exhibits non-combustible fire resistivity properties. They have good electrical conductivity, and that good means the it is good for uh, the material is good, and the electrical conductivity of the material is minimal. So in case of electrical supply, the glass will behave like a resistive material. It is entirely heat resistant, that is heat does not impact on its size or volume. It is non-absorbent. It exhibits resistance to the action of majority of chemicals. The density of the substance is rather low, measuring approximately 65 kilo per meter cube. The thermal conductivity of this material is rather low, that is measuring approximately 0.0332 to 0.034 kilocalorie per meter cube. The tensile strength of this material is approximately 8 times greater than that of the steel. If we have the other applications, it is utilized for thermal insulation regions such as household and industrial application like ovens, insulation of metal pipes of pipelines, motors, vacuum cleaners, and the walls of the roof of buildings. Glass wool, because it's a high chemical resistance, it is utilized for filtering corrosive liquids such as acid and acidic solution. It is employed for the purpose of electrical insulation. Additionally, these kind of glasses are employed for the purpose of sound insulation. It is also utilized for the air filters and metal for filtering dust. Additionally, it is employed in the production of fiberglass by the amalgamation with the polymeric resins. This is the end of the glass chapter. If you like this content, so hit the like button, share it, subscribe the Gurukulam Jyoti. Thanks for watching.